Now start this course. First one is your orthographic projections. So we have finished till now course objective, what are the contents, lettering, and why we need for your why we need this graphics, engineering graphics, then basic lines and curves. Then we are going to start, first one is your orthographic projections. 3D view, look at this view, 3D viewing of an object from any point in the space. Any object in the space, how do you view it? You can visualize 3D view. Then it has to be mapped in 2D. You have to draw in 2D. So consider, for example, as I said in the beginning of the class, take a glass half full water. Then if this is my glass with half full water, how your top view looks? I am looking at the top. How it looks? It looks like this. Then how is your front view? I am looking from the front. How is your front view looks? Then how is your side view looks? These are all called views or projections, looking at from top, side as well as front. Classification of views and principal planes of projections, angle of projections. This is the outline about this chapter. Classification of views, pictorial views. Pictorial views I can classify basically in two parts. One is viewing lines converge at a point. All viewing lines converge at a point. Look at this example, all viewing lines are converging at one point. This is called perspective views. Then other part is all viewing lines are parallel. This is called projections. So pictorial view has two, that means remember, one is your viewing lines converge at a point, perspective views, then viewing lines are parallel, this is called projections, this is called your pictorial views. Then perspective views again classified into three parts. First one is your one vanishing point. At one point all rays are vanishing, that is called one vanishing point. Second part is your two vanishing point, that means two parts vanishing, two vanishing point. Third one is called three vanishing points, that means in perspective views all lines are merged at one point, this is called your vanishing point. That means it may be one vanishing point, it may be two vanishing point, it may be three vanishing point, depending upon your perspective view. One vanishing point, two vanishing point and three vanishing points are there. Then projections. Projections again classified into two, viewing planes normal to projection lines and viewing planes inclined to projection lines. Viewing planes normal to projection lines again classified into three, all will be discussed later on: isometric, dimetric, trimetric. Then viewing planes inclined to projection lines again classified into three: cavalier, cabinet and clinographic. If I repeat it again, pictorial view classified as two. One is your viewing lines converging at a point, that is called vanishing point, and that point is called vanishing point. That pictorial view is called perspective views. Other part is your all viewing lines are parallel, that is called your projections. Then perspective views again classified one vanishing point, two vanishing point and three vanishing points. Then projections again classified viewing plane normal to projection lines, again this classified under these three. One is your isometric, second one is your dimetric, third one is your trimetric. Then viewing plane inclined to projection lines, that is your cavalier, cabinet and clinographic. So, this is all your classification about projections and perspective views. Now, come to orthographic projections. Each object can be seen to have principal planes. Each object can be seen to have principal planes. If I draw it, x plane, y plane and z plane. Then looking at these views, when viewing planes are parallel to these principal planes, when viewing planes are parallel to the principal planes, these are called orthographic views. Viewing faces, now viewing faces, if I take a glass box, inside this glass box I put an object, then this is my object inside a glass box cube. Then if I am looking this object from here, from this side, this I called front view. If I am looking from the top or top face, this is called top view. Then depending upon left and right, it depends upon the how you are viewing, then it is called left hand side or right hand side view. There are three principal planes or faces of projections. If I divide it into, then it will be front, top and side. Front, top and side, this is your side. So, the three principal views are projected on three principal planes of projection. Front view is projected on the frontal plane. Front view is projected, remember, on the frontal plane. If you come here, this is your frontal plane. Front view will be projected in the frontal plane. Similarly, top view will be projected on your top or horizontal plane. Top view is projected on the horizontal plane. If I take it, this is my frontal plane, this is your horizontal plane. Similarly, side views are projected on profile planes, both the sides called profile planes. A side view may be either a right side view, it is called RSV, right side view RSV, which is projected on a right profile plane, or it may be left side view LSV, projected on a left profile plane. Most simple objects need only two orthographic views, either top front or top side or front side. Describe them completely. Some complicated objects require three or more principal views to describe them completely. Now come to your third angle projections. Come to third angle projections. Look at here. If I say this is the observer, this is the picture plane, this is the object. Image is formed in front of object. If this is the object, observer is fixed, image is formed in front of object. Now come to first angle projection. In first angle projection, image is formed behind the object. If this is the object, image is formed behind the object. Look at the difference. In third angle projection, image is formed in front of the object. In first angle projection, image is formed behind the object. The difference in the third angle and first angle projection methods is mainly in the relative position of the picture plane and the object. The position of observer remains the same. The position of the observer, if I am observing, it remains same. All the principal views, that means top, front and side, would be identical whether you draw them in third angle or first angle scheme. The only difference would be in the relative position of the different orthographic views, which is due to the manner of opening of the principal planes of projection after the image have been formed or projected. The views are always opened by keeping the position of the front view stationary. Remember, we will discuss it. The views are with respect to your front views. Front view is your stationary. how you are opening the glass box. As I said earlier, one object is inside a glass box. With respect to your front, how you are opening, that depends upon your first angle and third angle, and it is only relative movement, but here front view is always stationary. How to remember difference between third angle projection and first angle projections? In first angle, object is encountered first. If observer is stationary, that means object is encountered first. That means in the observer, in front of this observer there is object in first angle. In third angle, the object is third. That means picture plane will come into picture. Behind your picture plane, your object will come into picture. This would help in drawing the different views in their correct positions. Look at here, frontal plane. If I draw a frontal plane like this, parallel projector perpendicular to the frontal planes, the projectors are parallel and it is perpendicular to frontal plane. Here it is also perpendicular to your frontal plane. Third angle projections, example, this is your object. I am looking from this side. Once you are looking from this side, what is the basic example of third angle projections? How to distinguish? Observer is here, then object is your third. Observer, picture plane, this is your observer. Picture plane, PP, picture plane, then this is your object, as I said. Then this will be your frontal plane. Then respect to your frontal plane, this is your horizontal plane. Then side view, as I said, this you can say this is your profile plane, this side and other side. Then look at how in the frontal plane object has been projected. From here to here it has been projected. So this is your perpendicular to your frontal plane. Here it has been projected. Then here it has been projected, how it looks in frontal plane. Similarly, in horizontal plane, in profile plane, draw it projected back. Similarly, in horizontal plane, draw it. These are called hinge lines. This and this and this. As I said earlier, frontal plane or front view is stationary. That means with respect to front view you have to rotate. That means this part is your stationary. Then next part I rotate it with respect to frontal, with respect to this hinge line, this has been rotated, it has been rotated. So now front view and is your horizontal plane here rotated, this is your top view. Then again with respect to frontal plane or front view, again with respect to this hinge line, it has been rotated. You see, it has been rotated. Now this is your profile plane. Look at here, object is here, frontal plane, horizontal plane, profile plane. Then if it is your frontal plane, then this is your front view, and if it is your horizontal plane, this is your top view. If this is your profile plane, this is your side view depending upon right side view or left side view. In this, in case of third angle projections, because it is the right side, it has been rotated right side, so it will be right side view RSV. Third angle projection, here is your object. So as I said here, if you look at here, front, top, right side view, top, front, right side view, front, top, right side view. So principal projections, horizontal, frontal and profile. Opening a glass box, as I said, opening a glass box with respect to your frontal plane. Here if it is in case of third angle, if you look at here, this is your frontal plane. With respect to frontal plane, this horizontal plane has been rotated, so it is coming back here. Similarly, profile, it has been rotated with respect to this, it is coming back here. I have finished up to third angle projections. Let me stop here. Next class I will start with this your first angle projections, then followed by few examples how you have to draw in third angle as well as in first angle projections. Thank you.